So the lab we just did was talking about how does the acceleration depend on some other things. How does it this dependence on, and the first thing was the applied force, and the second thing was the total mass. Now remember that for applied force we actually used as a proxy the mass on the hook, on the hanger. And we did that because we haven't talked about forces yet, but it's fair to say that the more weight you put on the hook, the harder the hook was pulling on the entire system. So we'll come back and justify that in full, almost incidentally, but right now that's what we're looking for. So when we make a plot like that, all right, so in this case, in both cases, these are some sort of mass, some sort of mass over in as your independent variable and acceleration as your dependent variable. And there are a lot of different ways things can depend. Two that we're going to look at are they can be linearly dependent, linearly proportional or dependent. And in that case, we imagine we get a line, preferably going through the origin, right? That the acceleration is some constant times the mass. But there are other possibilities, and another one you might have seen that you will see in one thing is that when you plot A versus M, you get something like this. Oops, not quite that bad. Instead of being linear, it's hyperbolic. This is called inversely proportional. And that means that A is some other constant over the mass rather than times the mass. So the point of the lab was to figure out which of these cases happens for each of the two cases we said here. It will be true that one of them is linear and one of them is inverse, and you're asked to figure it out. And to be honest, you probably can just look at the A3 and B3 graphs, which are the ones plotted straight versus the mass, because they'll either look linear or not. And it would be okay to work from there. But the point of the problem, or the point of the second part, which was the thing people have found confusing, is I talk about linearizing an inverse case. So let's take this case. Let's talk about this case. If the actual relationship is inverse, it's inversely proportional, such as shown here, where you get hyperbolic decline, or that the formula is C over M, we can do a bit of a trick, and we can say, well, that's the same as saying C times 1 over M. I've done nothing there. And I'm going to say, so let me define a new variable. I'm going to call it I, which is just the inverse mass. Then we see that A is now C times I, which means in terms of I, in terms of this new variable I, if I plotted A versus I have constant times the variable. That's just linear. That's just linearity. So the idea is that I can turn an inverse proportion into something that looks like a line by plotting 1 over the variable. So the A4 and B4 graphs of that lab were meant to say, just does it come out more linear? And the idea being, if the A versus M plot comes out to be linear, then the relationship is linear. But if the A versus 1 over M plot comes out to be linear, then the original relationship was inverse. Like I said, you really could probably tell with the data that you're taking just from the straight up plot. And you no longer really need to do this. This is, to be honest, an artifact of historical limitations where it was very hard to figure out what would the value of C end up having to be. In this case, that's not easy to see. Whereas over here, the value of C is, of course, just the slope. So it was easy to find that value by linearizing. In a modern age where you can use computers to fit for you, it's less important that you be able to do that. So really, honestly, although you should make that graph, it's not going to tell you as much as historically it would, or it's not as useful. Lastly, if you're going into Desmos, it won't let you have a column, right? If you go and you have, here's your column, and you want to plot your accelerations here, it doesn't let you do 1 over m as a column header. So I would recommend, and certainly will accept, that you instead call this thing just I for the inverse mass. And then when you plot, you can say I'm plotting inverse mass, and so down here this would be in units of inverse kilograms. And that's just an aside thing, just a naming thing.